Arithmetic sequence. So an arithmetic sequence is a sequence that you add to get to the next term. Okay? So with these two, these two are examples of arithmetic sequence. Find the 9th term of each of those, please. So I got 76 and 55. Okay, hopefully you took each one and went, etc. Okay, so that's an example of a recursive arithmetic sequence. So this is another example. However, as we mentioned before on the last one, what if you had to find the 40th term or the 300th term of the following? I mean, I guess you could do it, but why? Seems like a mess. But we have a formula, and you may recall it from algebra. You did do this in 8th grade, where this was your formula. Okay, where D is your common difference. You already know what N is. AN and A1, you know what those things are already. So D is just your common difference, and that's how we get from one term to the next. So to find a common difference, all you do is take one term, so in this case 11, and subtract the term before it. So any term at all, and subtract the term before it. So I guess you couldn't take 8, couldn't be your first term. So our common difference here is 3. That's how you find it, and in that case. So what is the common difference in ours? Well, we just figured that out. That was 3. Okay, one term minus the one before it. So when we move on, if we can use this formula that we have here to find an explicit formula. An explicit formula is like the original formulas that we had, where you just had a formula and you could plug in, say, if you want to find the 40th term, like we want to here, you could just plug in 40 and get the answer. So these formulas here will give us the explicit formula. So the first thing that you always need is that common difference. So we have that. The second thing that you need is your first term. So our first term is 8. And then we need to find our explicit formula. So that is A sub n is equal to, I'm just reading it off. Actually, I like this one better. A sub 1, which is 8, plus D times n minus 1. This is our explicit formula. Now, generally, we multiply it through, do the math to make it a nice formula and not just weird looking like it is. So I get, that's my explicit formula. So what that means is it finds any nth term that I want. So sometimes this says find the nth term. It's not ninth, it's the nth. This is n, so explicit formula. So if I can use this to find my 40th term, just like we have in the past, 3 times 40 plus 5, just plug it right into this. And without having to do the recursive piece, I now know that 125 is my 40th term. Okay, so we want to take recursive equation or recursive sequences like this and create an equation where we have an explicit formula where we can find any term that we want at any time. So what we always need first is our common difference. So always, always, always find that common difference first. Then we need our A1, and that will help us find our A sub n using our formula that is above that you can't see right now. So the common difference again is take any term that you want. So I'll take 15. Doesn't matter which one you take. Subtract the one before it, so minus 9. So 15 minus 9 is 6. Perfect. So now I have my D. To find my first term, well, that's the first term. So that's 3. Now we just take these and plug them in for my explicit formula. So it's the first term plus the common difference times n minus 1. So then doing the math here, A sub n is equal to 3 plus 6n minus 6. A sub n is equal to 6n minus 3. So using that, I can find any term that I'd like. Excuse me. So try this one. Please try number 2 on your own. See if you can figure that out. So here's what I got. Please note that the common difference here is negative because this is going down. So since we're going down, we have to, the common difference is I'm adding a negative 2. So 16 minus 8 is negative 2. We have 18 as the first term. Do all the math. Negative 2n plus 20. Alrighty. So number 3 here. So what we need to find here, again, always, always, always the first step is to find that common difference. Got to do that first. We have our A1. That one's okay. A1 is 8. But that common difference, that's a little bit harder because I only have 2 random terms here. Now, you might be able to figure it out in your head, but we can use our formula, the one that is on the previous page, to figure this thing out. So let's remind you of the formula. A sub n equals A sub 1 plus the common difference times n minus 1. We can plug, we have 2 terms here. Okay? We can plug them in to find it. So I'm going to take A sub 8 and A sub 1. Now, I do this in 2 steps just to show you where I'm getting the numbers from. So I don't know the D, but I know n right now. Okay? N is that 8. Okay? Remember, n is the term number that this is equal to. So this and this always match. Okay? So now I do know what A8 is. A8 is negative 13. And A1 is 8. So now I plug them in. I just do this in 2 steps to show you D times 7, like the process. Okay, you can do this all in 1 step and jump right to here if you want. That's perfectly acceptable. So negative 21 equals 7D. Divide by 7, and D is negative 3. Now in this case, the slope formula is acceptable. And if you could do the slope, that's fine. But when we get to geometric, slope doesn't work. So I want to get you good at it on the easy ones and these arithmetic ones. And so this is easy. So they want to find the 23rd term. So we don't have to find the explicit formula every time. So I now know my common difference is negative 3. So I can use these 2. I'm going to just take them over here. My D is negative 3 and my A1 is 8. And I can use these 2 in the formula with my A23 is what I need to find here. Okay, so here I go. So I want to find A sub 23. Now you could find the recursive formula, the explicit formula if you wanted to, but I don't. Okay, I'm just going to plug that 23 in there because these 2 always match. Minus 1. So that's my formula. Okay, that's this formula I'm using, but instead of A sub n, I'm finding A sub 23. So you could find the explicit and then plug in 23, or you could just do the math here and figure out that it's negative 58. Just, plug that in, do the math, and you're done. All right, so same kind of thing here. Take a second. I'd like to see if you can find that common difference. So again, that's the first thing you got to do. You have these 2. Can you plug them in and find the common difference? Okay, so I got my common difference to be 3 this time. Here. Okay, I plugged it in. My A4, so I put 10 here, 1 here. This 4 and this 4 have to match, so 4 minus 1 is 3. And then just solve the equation. So from there, I want to find the explicit formula. So find A sub n. I need my A sub 1. So I just plug it in. A sub n is equal to 1 plus the common difference times n minus 1. Just do the math. Just do the math, and I get 3n minus 2. Okay. If A sub n is 52, what is n? So this is the option instead of just plugging in. If A sub n is 52. I knew that. So this is the option where they're giving you the y value, in other words. So this is our explicit formula here. They're telling you what this is. That's like the y, and this is the x. They could use x's and y's, but whatever. So then we just simply solve here. So 54 is equal to 3n, divide by 3, and n is 18. So in the 18th term, and if I plugged in 18 here for n, I would have gotten 52 out. Okay, and then we have these word problems that go along with it, of course, because word problems are applications, right? So Megan is getting better at math. On her first quiz, she scored a 57. Then she scored 61 and a 65 on her next 2 quizzes. If her score continues to increase at the same rate, what will her score be on her 9th quiz? So what is it increasing by every test? So when she goes from 57 to 61, that's 4 points. 61 to 65, that's also 4. So that's the common difference. What it's going up by is your common difference. What's her first term? Well, on her first test, she got a 57. So an explicit formula, that means write a sub n. What is a sub n? So a sub n is the first term plus common difference times n minus 1. Multiply it through. Plus 4n minus 4. So the explicit formula is 4n plus 53. Now we have our explicit formula. We can answer any question that we want. Use the formula. So they're telling us we have to use that to solve the problem. So the problem is, what did she get on her 9th quiz? Well, her 9th quiz would be a sub 9. So I plug 9 in for n. And it looks like she got a sub 9, looks like she got an 89. So write your final answer as a sentence. It is always a good idea when you have a word problem to answer the word problem in words. So Megan should get an 89 on her 9th test. Good job, Megan. All right, have a great day.